Okay, now we'll continue. Uh, yeah, for some t of n minus I have this equation. Now, what I'll do is, this is my first equation, my second equation, so on. So what I'll do is, I have my t of n minus 1 value over here. So I'll just substitute this அப்படியே இதை எடுத்து நான் இங்கே போடுறேன். So what I'll do is, t of n becomes t of n minus 1 பதிலா t of n minus 2 plus 1 from this first equation plus 1 from over here. Okay, that will give me t of n minus 2 plus 2. Okay, this is my t of n value as of now. Again, I know the value of t of n minus 2 in terms of t of n minus 3. Okay, wow. So again, my value becomes t of n value becomes t of n is equal to t of n minus 3 plus 1 from over the second equation plus 2 from our previous equation. T of n minus 3 is equal. So, okay, sorry, t of n minus 3 plus 3. Correct. So what I'm doing is like இதே மாதிரி continue பண்ணா, see, for some t of yeah, so for, instead of like அப்படியே இங்க substitute பண்ணிட்டே போவோம். For each and everything I'm just substituting above. That's it. 2 எடுத்து 1ல போடுறோம், 1 எடுத்து திரும்பி இந்த equation போடுறோம். So if I can just continue, see, t of, for some k integer, this k, let me take instead of 2, 3 or 4, I'll just take for some k integer. Okay, wow. N minus. Okay, so here when I substitute t of n minus 2 in this first equation, n minus 2 in the first equation, so so when I substitute t of n minus 2 in this equation, see, plus 1, I'm getting this plus 1 from the equation itself and plus 1 from the previous equation. Correct? So that becomes, when I consider like, yeah, so this plus 1 from the previous equation and plus 2 from its own equation. That when I consider this 2 as k, okay, well, instead of 2, 3, I'm just putting k. Instead of 2, 3 or k, I'll put, what I'll do is I'll take 2 as k, so I'll get this, the, oh, so இங்கே வந்து k plus 1 ஆயிடும். Correct? So t of n minus k plus 1 plus this 1. So like yeah, so when I add all these 1k times, it will become k. Okay, wow. So just see, when I have 1 here, I have 2 here, I have 3 here. So for k, I'll have k plus 1 plus 1 from me this original equation. Okay, wow. All right. So we have got our like final equation. Now, since I know, like, okay, this is my final equation. So I have to convert this t of n minus k plus 1 to t of 1 because I know the value of my t of 1. Okay, well, somehow I just have to convert this into t of 1. So I'll get my value of t of n. So what value of k? I'll get t of 1 over this whole thing as 1. Okay, you can just solve it. You feel like if it's too complex, you can just solve it over here. T of n minus k plus 1 should become 1. That's my goal. T of n minus k minus 1 equal to 1. Right? So k becomes n minus 2. Yeah, k becomes n minus 2. Correct? So yeah, for k is equal to n minus 2. For k equal to n minus 2, this equation becomes t of 1. Okay, so I'll put k as n minus 2. T of n becomes t of, this becomes 1, t of 1 plus k is n minus 2, n minus 2 plus 1. All right, I know the value of t of 1 is nothing but 1 itself. So 1 plus 1 minus 2 plus n. Yeah, so I got my value of t of n. So this is my value of t of n. That's it. This is my time complexity of my f of n of my recursive function, sum of n natural numbers, recursive. Okay, so this is how you analyze recursive. This is how we analyze the count for recursive functions. We used the help of recursive relations. So it's important to know that. All right. What's next? What do we have next? Okay. Next we have trees. We'll get into trees. Tree ADT. Yeah. So tree ADT. I'll only be taking tree terminologies, definitions, and that's it. That rest of them, the rest of the part they'll cover. So yeah. What is a tree? Computer science tree is an abstract model of hierarchies. Okay. Okay, what's a tree first? See, the tree is actually a fundamental concept in computer science, actually, that models hierarchical relationships. Relationships now, a parent-child relationship. Okay, wow. Parent, parent is a boss, and then child is inherited from the parent. Okay, wow. When they have these type of relationship, that is called a tree. Okay. So now tree, unlike linked list, we have a linked list listed array எல்லாம் வந்து it's all sequential manner of saving arranging data arrangement. Just add one அப்படியே ஒன்று பக்கத்துல ஒன்று ஆட் பண்ணிட்டே இருக்கும். But tree is not, tree is a non-linear data structure, right? Tree is a non-linear data structure. It represents parent-child relationships. Okay, these two are main key points. And then, okay, so that's pretty much trees. That's what a tree is. Where do you use trees? Trees are used in organization charts, files. Okay, file system la they use majorly trees. When you see file explorer, you get. Yeah, so sorry. So you use tree editing in file systems to constructing file systems. Yeah, okay. We'll see what is a tree first. I'll start defining tree definition, tree terminologies. Okay. So tree looks like this. Mm, Yeah, tree looks like this. Can I have as many number of this nodes? Okay, we'll see what is a node first. Okay. So this is how a tree looks like. Okay, wow. So these small circles are like data points. This is where our data gets collected. Okay, wow. So these small circles we call them as nodes. These nodes holds our data values. Okay, wow. So this is our nodes, and our very first node where the tree emerges. Tree எங்க start ஆகுதோ that node is called the root node. The node is called root node. Because அங்கதான் நம்ம tree start ஆகும். Alright. And where a tree ends, tree எங்க end ஆகுதோ, see these three nodes, that's where my tree ends. Okay, wow. There's no child after this. There's no children after for them. So I call them leaves. Those are called leaves. Leaf of the tree. So we know what's a root, node, leaf. Okay. Now, okay, these links, the link இருக்குல்ல, these links are called edges. Edges are nothing but they are the links which connect a parent and a child. Okay, wow. Okay, we have root, node, edges, and leaf. Okay, so these are four terms of a tree, and then we have, all right. Okay, we have height and depth. Height and depth. Okay, so height. What's first? We'll see depth first. Okay, depth na enna first. Depth is like how do you what do you mean by depth? Depth na we start from a point above and then we measure the distance this the distance from above to till end. That's how we measure depth. That's what we mean by depth lab. So same அதே மாதிரி இங்கேயும் I measure my distance from the top to the till the end till my leaf. So I'll start from the root node. Root node is my level 0. Okay, wow. So this just like a building, okay? It's just like a multi-story building. Root node is my level 0, and this is my level 1, and these are my level 2. This is my level 3. This is my level 4. Okay, wow. All right. See, one important thing to note is depth. We don't talk depth in terms of tree. We talk depth in terms of node. Okay, wow. Depth of a tree doesn't make any sense. அப்படின்னு ஒண்ணும் இல்லவே இல்லை. Depth of a node. We can ask what is the depth of a node. Okay, wow. If I want depth of this node, it's one. It's one. If I want depth of this node, it's three. If I want depth of this node, it's four. Okay, wow. There's nothing called depth of a tree. So, all right, what is the depth of this node now? One. Depth of root is always zero. Okay, because it starts from zero. Depth measure பண்றது will start from root only, so it's always zero. Depth of leaves is the maximum. Okay, that's a maximum depth you can go. So that's what you call depth. Start from above and you measure these level one by one. Right? So yeah, that is depth. And height. We have height. Height, what do you mean by height? Height is again like you start measuring from down and you go upwards. So you'll start measuring from, that's what you mean by height. Height goes like this. Okay, wow. This is height. And one major difference between depth and height now, we don't talk height in terms of nodes. We talked height in terms of tree. Okay, wow. There's nothing called height of a node. Okay, height of this node, height of this node. They only define height in terms of tree. All right. So this will be my okay. The deepest leaf will be my zeroth level. Okay, wow. The distance between the root and the deepest leaf will be my height value. So these leaf level will be my level 0. This will be my level 1, and this will be my level 2. This will be my level 3, and this will be my level 4. Okay, wow. So what's the height of the tree now? You should say it's 4. That's it. Height is 4. All right. Okay, these are just pretty much terminologies of tree. We don't have anything else, I guess. Oh yeah, we have subtree. We check if I have that. Root, internal leaf, depth, height. All right. Yeah. We have subtree. What is a subtree? See, the name itself, it's the name is itself evident. See, subtree now, if you consider these three nodes, இது மட்டும் தனியா பாத்து. If you see this alone, these three nodes alone, see, I can see this. I can say this root. Can see these two are children of this root. Yeah. If you see this two alone, if you see these two nodes alone, I can say this is my parent node. This is my child node. If I say these three alone, this is my parent node. These two are my children node. Yeah. Okay, so these are like small trees, just the small tree which makes up this whole entire tree. Okay, so that's what we call a subtree. Subtree is nothing but it's just a portion of tree. These are like self-contained trees. Yeah, a tree inside a tree. Yeah, so that's pretty much subtrees. Uh, okay, okay, yeah, all of them. Tree terminologies. That's it. I'll give a small introduction of a binary tree. What's a binary tree? And then we'll wind up this session. Binary tree. Okay. So actually tree ADT can be like tree ADT na அதுல நிறைய இருக்கு actually. You can branch tree ADT branches into many different trees. Actually, you have binary tree, you have B trees, you have BSTs, you have AVL trees. So like just like a linked list. Okay, linked list la we have singly linked list, we have doubly linked list, we have circular linked list, we have a doubly circular linked list. So we have so many linked lists. So same likewise, we have so many different properties of tree. What's a binary tree? Okay, so I have my root node. But what's a binary tree is like defined. It's defined like every node should have maximum of two children. Okay, it can have zero, it can have one children, it can have two children. It can't go beyond two. Okay, that's what I call a binary tree. So this can have two children. My root node can have two children. This can have one children. This can have again two children. Again, I can have two children. This can have zero children also. That is also allowed, but it can't go more than two. In general, if we talk tree in general, it can have as many nodes as possible. But if we talk about binary tree, it should have a maximum of two. It can't go beyond two. That's what I call a binary tree. Okay. Um, Yeah, okay. Again, the same, it's same, just follows everything same, just as tree. You have data points, you have the roots, you have a leaf, you have height and depth, you have depth of node, you have subtrees over here also. Mm, yeah, that's it. That's pretty much binary tree. You will see in details tomorrow what's a binary tree. Uh, that's, I guess, Amazon and all will take. Okay, fine. That's it for today. Uh, I hope it went well. So yeah, guys, thank you. Thank you for joining. Thank you for joining. Thank you so much. You can leave the meeting.